Hello, everyone, and welcome. Welcome back, finally. Last week was just a practice. We're gonna hit our targets this week for sure. We're gonna be continuing our coding project today, see if we can get through the floor flow generation. And if that works, we can make enemies that will avoid things like walls. Before we do, though, let's check in with the kitties. We do have Ember in her spot. Molly hasn't taken it yet. Sky up in the tree. Sherbet was visible by the TV moments ago. And Mason is on the bed. Let's see. Sammy is overlooking the food dish. Sherbet was on my chair back until moments ago. Hey there, Key. Welcome. Put it on the tree. Well, hello, Sherbet. Hey, bud. Sherbet has come by for ear scratches. Yeah. Okay, so this is a proof of concept bit here for our floor flow generation. Yeah, we added an extra half hour just to make sure the thing that would have bumped the schedule off that necessitated that didn't end up happening, but the extra half hour was still useful. Made sure things still happened. So what we're doing with this one is we're taking our input image, our floor texture. We're using a output buffer here is what will result. It's a texture of the same size. And we also pass in information about the scale of the floor texture. We're going to go through and we're going to look at it and say, if this has no alpha, if it is an empty spot, as far as well, not necessarily, but that's what it's doing right now, is it converts empty spots into an image. Well, here we'll show more of the code. Not describing this very well. Okay, so right now we're creating a 10 by 10 image, and we are setting the edges of it to effectively black here. I think probably white. It doesn't matter. We're making a color in it. Open our project folder here. And we should have in data and flow, we have our little X here. Now, right now, this is running in line. Hey there, Lunar. At the peak overcooked XCOM hybrid minigame where you fight anthropomorphic animals in fedoras. I recall there being a kind of lightweight tactics game that actually had a mechanic where you kind of spliced your soldiers with animals to give them traits. Supposedly based on like commentary about it, they sort of undercooked the content design a bit, but that was an aspect, is that you would eventually have like hybridized animal soldiers. Hey there, James. Okay, so we generate this at some point. we get our floor path here. I'm going through where I got with the floor flow generator here, both to justify the stalling, but also to figure out what exactly we were doing. Okay, we are passing in X here. That's where the X is coming from. So in theory, I might have to make sure that I nuke that, but go back to here and we're going to look at our X. These are EXRs. They are high def files. Okay, that's 1/255. Let me get a sample of this. They're getting nothing. So I think we might be getting integer values here. That might make sense. Now they're vector 4s. Let's see. Okay, these are integers all, so let's force them all to be floats. Floats. Okay, we're going to go back over here. GLSL didn't like that. Of course, it didn't. Line 34. Might just be a GLSL syntax going on here. Same issue. What can we do to force that? Might just be, again, syntax. Just don't want to have to look it up if I can avoid it. Okay, syntax. We are going to force all of these to be floats to make sure that I'm not just getting integer math issues going on here. Technically, that first one should be enough to force it. Let's start there. That. Run that. And that. Open this. There we go. Well, that's way over limit. Because this should be... the matter, Sammy? Come here. Sammy's crying in the background. Sammy. What? Says, well, I want to jump up on the table, but Sherbet's in the way. See if you can spot some of half of the face off here. This is a classic cat what? I'm not stopping you kind of scenario. Dammy. Oh no, now she's just sulking. Okay, so why are we getting such large values here? So we're storing the texture, and our red and green values are being stored as the integer here, the counter, which goes from 0 to the width of the image as a fraction of 255. But we're getting a much larger number than that. Which implies I think we need to do this. Because I think it was translating that out into a bigger number. Able to, yeah, we probably were blocked from messing with that. I bet we got an error for trying to mess with a file that was already opened. There we go. There we go. So we're getting our fractions of the distance here. So how we'll be doing this is we are going to, for first pass, we are going to look around each spot some distance. And if we find, while we're iterating over that, if we find a wall, we're going to add a unit vector that pushes from that wall to the current spot. So let's say in this square here, in the lower left, we find a wall there and we are searching in this square, in the little green square in the lower left. We're going to put a unit vector that pushes back into that square from every wall that we find around it. So it's essentially shoving away from all of the walls. We're going to have to be cautious with how we do this because we don't want to paralyze everything. But this will be the nuance to getting this properly. Now, alternately, if that doesn't work, we go into these and just have a vector emanating out from the wall spaces, saying that it will add a vector for every open space it finds. No, wait, there's all kinds of ways that we can approach this. I haven't really thought it through fully, but the general idea is there. It'll totally work. Let's close that before I forget again. Okay, so if it's empty, we have a floor space. So now we're going to iterate a distance out. We're looking at search range and saying we'll search kind of left and right of the pixel that far, left, right, up, and down. So we're going to go from minus search, like our position minus search range, to plus search range. As well, X and Y. So we have discovered an empty spot. We're going to say we have discovered a filled spot. So there is floor defined here. We are going to then, for A is equal to I minus image data. Should be search range. A is less than I plus search range. Now we will be looking for ways to get some iteration in the local, but for the time being, we're just doing one brute force pass of this, largely because this isn't going to be happening frequently. Again, this would be once during like my build of the game after making a map, or when a mod file is detected for the first time, we would load this. So I'm not really concerned with this taking too long. There are other elements that we can make that will potentially take longer, but I'm still not worried about those just yet. Then we're going to do this again, which will be L. And this one is based off of J. These aren't great parameters. Is potentially very error prone what I am doing here. So let's do a spec for... No, we have color here. Okay. So if K is greater than 0 and K is less than width, and L is greater than 0 and L is less than height. Then we're going to check further. We could do this as a and here as well. Because we only need to know that it's greater than 0 and that it is less than the width. So that we could stop iterating here. So if we... Yep. Let's use that. And... is less than width. I'm sorry, and k is less than width. Hypothetical that as well, just to be sure. We'll see if that breaks down. Then same thing here. And L is less than that. So we can remove that. So we're just saying skip them until they're within range, because it will be within range. Eventually, it will be greater than 0. But if we're already past the width or the height, we're going to stop the loop. So we have a... Wait. Okay, yeah. Where we currently are is filled. Now we're going to look at all of the surrounding ones. So this will be back for... search color, we're going to image load, and we're going to say KL. Searched colors alpha is 0. Then we're going to say... So that is its position is KL, and our target location, our current square, is IJ. And these are always going to be offset in this fashion. It won't be a unit that we create. It won't be a unit vector that results from this. I don't know if there's a unit vector function in GLSL. If there is, I want to use it. So just a moment. Should be a normalized function. Okay, just call normalize on it. Okay. So the resulting vector should be a... So we're going to have a vector 2. And this needs to be from our empty space, our KL, to our filled space, our IJ. So it should be this one. So this is our empty space to our filled space. So we're going to originate at the empty space. And head to the filled space. And we'll normalize this. Now, it may not like this. Let's Do a quick compile. 33. What does it not like? These are coming in as a uint, so I should be able to just force that. We'll store these in locals. T3. Okay. The integer of that. Integer of the height. We use this frequently enough that it doesn't really hurt us to store it off in this fashion. We aren't repeatedly going to a data location to get it. I don't know what the cost of that is. It's probably effectively nothing. Don't really need that because we're not going to do it. Okay, so this gets us our normalized direction. And we are going to say color dot r plus equals direction x. I think it'll let me do that. Yeah. We're going to need to normalize that as well. Do this the other way around. Each one will only touch one of these. That will save us from worrying about this. Vec2 of color R. Equal to direction plus that normalized. I will speak to this mess in just a moment here. So what we're doing is we're coming up with a single unit vector. So we normalize it out to a 1 unit long vector. We're going to take the existing one that we have accumulated during this loop, and we are going to add those together and create a new unit vector. So it's too long now. It's 2 units long. And we are going to then store that off in this way. So we definitely have a unit vector. I don't want to risk... No, we don't need to do it that way. We just need to do this one normalize. Now, every time we've done this, we've added a unit vector. Since we've added a unit vector each time, they've all had the same weight. We can just normalize it at the end. Okay. Check that it builds. Does not. 66. Lost position in that. Let me... Yeah. Oops. Okay. To check whether we don't have it open, we run it again. And that, we're going to go in here. We're going to look at that image. Okay. Okay, we need to adjust that slightly. So if we get to the end, we normalize it and we set its alpha to 1. Run that again. End it. Reopen it. That doesn't scan. Okay, but it hadn't been compiled, so let's give it another go here. Okay, close the folder. Didn't mean to, but we'll run it anyway. Just changed. There we go. So you can see each of these on the upper left corner are pushing in. Each of these is pushing in correspondingly. So now we come up with a more complex image and look at what we come up with. Okay. We're still going to do this a bit algorithmically, which will be kind of a mess, but is what it is. Do 100. And we're not going to do the edges this time. We are going to use if I mod 5 is 0. And J mod 5 is 0. Okay, so it should be bands of black stripes, essentially, that we're creating. And now when we look at this, we should have a bigger image. So that's where we have the floor. We're going to set that to OR. Oh, what is the syntax for exclusive OR? Quick check. Parrot. Okay. Sure, whatever. Certainly don't use that much. So we're going to create bands of solid spaces. No, these create the floors when we fill them in. So we're saying if it's not in these stripes, so this should create a bigger area. Make sure we have nothing open, run that. And that, check this. There we go. So these are the open spaces. Where does this one push? And we're looking around in a relatively wide radius. We need more open spaces for this. If just gonna look at we're just gonna create vertical bars here. Yeah, we're doing proof of concept with our generation here. Okay. So we can see towards the edges of them. We're getting a greater weight on them towards the top and bottom, and that's not necessarily what I want. Because here and here, we get more weight on these. So each of these is pushing up against it and left against it, but there isn't any corresponding down to create these uniform stripes. We need to make sure that we don't miss that. Which means we wouldn't be ignoring ones that are out of bounds. We would be taking that and saying, consider that a open space, in theory. If we don't consider it a texture that we're passing in, and instead we just consider it a block of vector 4s, and then we stuff it back in an image, which is already largely what we're doing when we're extracting it, then we can have much larger data here. And that would mean we can avoid the problem of what if I join multiple maps together, multiple like floor tiles together. But at the very least for now, this is functioning. So the next thing we have to do is get away from this one. So we are going to try floor texture get image here. So we're going to try to get a texture of this texture key. If we can get it, then we will load the corresponding one and build it. Or we will skip loading it. We will skip creating it with all of this mess. This is what I was referring to. Image create from data is we could just pass a gigantic scary array of vector 4s for this and avoid the issue of having to pass a texture in. So we might end up doing that to allow us to have really big rooms. But anyhow. Okay, so we need to get our textures in there. So I'm going to have a PNG of this. Get rid of you. So I go data, textures. Go in here and verify. We're using PNG for this. Okay. Force the change. That's fine. Go in here and we're going to open this. Okay, we will do it as a bitmap then. Should have known that it wouldn't like that. Fine, fine. We'll make a new one. I probably broke it. Okay, you can definitely parse that. What? Sure, whatever. Scaling this guy here. That. Just a brush, and we need pencil. Let's do this easier. Solid fill, thin line. That. And we have like this. Like this. Like that. Just gonna... This is not the sort of map we would use. There are too many corners here. This flow logic is not built to handle that kind of thing. Nope. Get this saving in the right spot. Do. Data, textures, rooms, save. Okay, so now when we load this, we should be getting a flow marker for that particular one. Oh, that's not right. Not a number. Interesting. Okay, let's run it on the Godot side. No errors were indicated. What was our search range that we used? Using a search range of 5 for each one of them, but it's possible that it's failing during this. because we have a relatively long burst of it. This isn't terribly likely, but we can break it apart. Yeah, okay, this is going to cause a problem because we're doing 4, 4, 64 here. All right. So we need to get our global sizes accounted for. So in the same way as our collision, we need to get our x and our y and our z here. How are we going to break this up? We could just do x and y and break those apart. Because we get 1024. Math here. Math. Okay, if we do, yeah, all right. Okay, should be, we could just do 32 by 32 by 1. Yes. This one is technically accurate a lot, too. Okay. So now we need to do our global invocation X and Y. And each X and Y is a division of the segment here. So we know it's 32. Yeah, all of my programming ones have the little confusion. Okay, so we know the height and the width. We need to make sure that we're rounding up. Okay, and equal to float version of width divided by 32. And then let's get what our should be ceiling, but okay. Just had to needlessly truncated ceiling call. That as integer. I think this will give us an integer back, but let's force it. Okay, so we're breaking the image apart into 32 segments. We are still going to say that the actual eye is that the actual marker is oh man. We just need to start there. The other rules still apply. I is equal to width segment times global invocation ID X. A is equal to height segment. And we'll explain this in a moment. So we're breaking it apart here. Each one of these iterations, each of 1024 iterations is going to try to operate on a 32 unit long. I is nope. We'll keep that there for just a moment. That's not quite right. This will make it easier doing it this way. Plus that. Go through this. Okay. So we're starting at the beginning of a segment. No, that'll still go too far. I minus that is less than 32. Ugh. Nope. Okay, so this is int target x is equal to I plus that. I is equal to 0. I is less than that is less than 32. None of that's clean. All right, we're trying to break it into segments, and I want to do this as smoothly as possible. And segment, X segment start is equal to with segment times this. Segment start. We'll need this anyway. Or it's convenient enough to have this. So we are going to start here. And we're going to say that this has to be true, so we don't overflow the end. And I minus segment start is less than 32. So we're saying we start at the segment, we are still less than the width, and we have not filled 32 segments yet. And we are going to do the same for our J iteration here. And J minus segment is less than 32. So we're still using J in this scenario. We're still using K in this scenario because we're searching around it. So this should let us utilize, once we fix it here, 30. What does 30 not like? From uint to int. Oh. This is an unsigned int. We're using int elsewhere because there are going to be places that want it to be an integer. Actually, no. It's because of this. We could avoid all the integer stuff if we made this a uint. I think. $51. No, we're going to leave them as integers because we want them to be able to go negative in relevant positions. You can hear cats playing. Molly and Sherbet hanging out in the play area. Okay, we're going to check Godot again, make sure it compiles. Yes, it does. Close that. That. Look here. Still getting not a numbers. Disconcerting. We store off the direction and build that up, then we could avoid calling normalize on the color. Let's just comment that out. Try it again. Run it in the Godot side, see if we get an error case anyway. Similar problem. Okay, no, we're getting zeros now. That's better. Are we loading it in? Oh. We're messing with the image there. That'll cause a problem. Well, and that will have caused a problem there. Run it again. Well, that didn't change it, but we're still in the 0 range, which is good. We should still be getting something that is from 0 to 1 in each color. And we are getting those ones set in there, so that's part of it. We shouldn't be setting pixel on this. That should be the normal format that we've got. Yeah. This should be a classic PNG format, RGBA, with 8 bits each. We have a whole half float here. That's our output one. Input should just be getting the black values. Jump in here. We aren't getting an error, so it shouldn't be a problem with the buffer. $500 by 500. We have a floor RID here. We're going to take this and we're going to extract it and make sure we are getting something out of that. Well, we're definitely not here to take over the world. That would not be in line with the Catbot Corporation corporate tenets. Doesn't seem right that it's beginning to end 255. Wait a minute. There we go. Did you see the problem? When Paint did it, Paint filled in white, explicit white. That's not what we wanted. I forgot to make it a transparent layer. Oopsie doopsie. There. Now, to go to our flow data, we are going to delete that. Double check, make sure we don't have anything open. We're done with you. And that, open this. Okay. Those don't seem right. Nope, those are okay. These have no movement to them. We're searching within 5 pixels for other surfaces. So you can see the closer we get to a wall, we start to get movement. And this is what we're looking for here, is that we want the movement to be unimpeded until you get close to a wall. So if we increase the search range out, if we go into our algorithm up here and we say that search range is a bigger number, let's say 25, actually 32, a whole giant segment. We get that. Now, that's going to make it so that there are overlaps, like across the wall. You can get some oddities here. So like from here, we can hit open spaces so that we get some distortion there. And that's part of figuring out how much wiggle do we want to have? What's the maximum distance between walls? Because again, over here, we are influenced by this space over here. These are open pixels, so they don't push back. So the impact of this space, there isn't as much stuff here to influence the resultant unit value. We'll see. We'll see. There might be some more fiddling that we need to do. Like, we could have the presumption that there are a bunch of 0 vectors put in, or a bunch of vectors that will add weight to the process, but we'll need to figure out how to do that. That is, we always divide it by anything that's entered into like 1/32 kind of stuff. But that shouldn't really change the resultant vector. Okay, so then the next thing to do would be to combine them with the movement vector and say, okay, I'm going to look at this one and I am going to look at the other and determine. Is my noise filtering glitching out again? Let me check here. Not sure. It's possible. I'm not hearing anything else. Is there something that you're hearing? So I am getting a little bit of flicker at the end of some of the audio. So I know I had an error sound come through Windows earlier. Let me flip some switches to be sure. One moment. Sound will go out. Okay. Should be working properly now. Well, as best I can. Let's set this back to a reasonable range. We're going to say 16. Close this. We're going to run it again. Take a look. There's our PNG. That won't change. This one, though. Okay. We still have some anomalies, like, in some of this, but it doesn't look like we have spillover. So that should be okay. So now we're going to say we're going to get this whenever we are doing this type of movement. So let's do an interim save here. Okay. Oh, proof of concept generation. That is still likely. There's probably some stuff that's getting through. Oh, and I should probably show you the window again. Broadcast is starting to fail me, so I may need to find another local filtering solution. Have that. We aren't using these. Get them out of there. So now when the entity moves, so that is going to be an entity behavior message. It's part of the game for entity and then behavior, then movement. We have move on grid. So we're getting the flow to center out of the flow generator here and setting it. We're saying check within the bounds. We are going to ignore that as far as room. We're going to be looking at it and saying if they are within range of the room for now. So we have a target. If we're in bounds of the movement grid, we're going to use that. This is going to be a bit of a mess. We're going to use this one for now. This will slow things down quite a bit. You. Is going to return an image. And we are going to use our position on the grid. So we're going to say if entity position x is less than floor flow get width and grossly inefficient variant. We're going to be, to make this work, we are going to need to have this stuff cleanly in position, you know? Okay, so then entity velocity plus equals and pixel is equal to movement dot normalize Okay, we're definitely running into error cases here. Hello. Now. All right, let's store this off so that we don't run into problems. Equal to that. Okay, now we have that image stored off. We don't need to retrieve it each time. It does create a waste that we're doing it a lot. I should do this on the... Oh boy, that's spinning like crazy. Let's do it on the Godot side and see if we get an error case. Interesting. Saving as PNG instead. Well, we've definitely got a flaw case there then. Because the resultant file that we're getting back isn't the same format, according to this. Well, we shouldn't be saving it each time. Okay, our file string should be our data flow floor test.exr, which should exist. Ah, we're recreating it each time. This go better. So we're going to load this from file each time, so that's going to cause a problem. We'll think on this a little bit more. Quick break, and I will be right back. And we're back. If our flow is null, there. See if we can get it functioning here. Oh. Okay, well, this isn't right. So the ones on the edge here are just zooming in, which means their movement is skewed. Okay, just a moment. We'll just get this here. And let's make this is effectively, is this in the bounds of... Okay, and we don't want to do... No, that's okay. At least it should be. Only interested if they get here. So it's only the ones that get within about this range here that it should matter. So this group, the lower right area, should start distorting once they get, again, kind of in this box here. It's 500 by 500, so it's super small. There we go. Okay, they're in 0, so it doesn't influence it. Okay, we still have some that are going haywire here. Should always be unit vectors. to this. If floor vector does not equal vector 2 dot 0. We do that. This is going to need so much scrubbing. This is going to need a lot of cleanup once we get there. The fact that we're getting some of them out here. Oh, no. Okay. It should be this space here that they're starting to be influenced. That is huge. That is way too much. That's why they're zooming. So you can see them massing up in shapes here. The general idea is correct, but I'm not getting unit vectors out of this. We're going to force the normalization and see how it goes. Really like this particular piano piece. All right. First ones are hitting range. Okay, it's that the vector isn't being normalized. And we're still getting very extreme motion out of that. Oh. Floor vector. We were testing based on floor vector, but we weren't implementing floor vector. We weren't using floor vector. Further down here so they hit that box sooner. So we know that the shader isn't emitting normalized values properly. This is still potentially okay. We just need to be careful. All right, we're still getting lurching motion. Look at that. On Those are way bigger numbers. Yeah, we are... Oh, okay. Times delta. That needs so much scrubbing. That is just so messy. We weren't applying delta, which means things were moving about 30 to 60 times faster than they should. Which is what will get you that horrible teleport. Let's see, we have Mason, Sammy, and Molly on the bed currently. We want to get as many of them into the target zone as possible here. Okay, you can see them hitting the shape here. Now they resume moving forward when they hit a space that is empty on the floor. One of the things we're going to do is say, you can't move there. But for that to work, we need a continuous shape. We have a we're using a here. Let's clean this up a little bit more. We are going to divide it by 96. We're greatly multiplying the size of that. Now we're also going to go in here and we need in our data... Let's do 500 of them. I still have concerns about that it's saving as PNG, or at least it's claiming that it is. This is 500 of them. Now we should be seeing... We should be seeing a lot more of them hit those. I think I may have done that backwards. So these can't reach me. Let's verify. They're potentially in one of these regions, in the square regions. But this is the kind of thing that I want. Now, how to properly blend this, less sure. But there will be areas where it's like, no, it's pushing hard against them. They can't get out of that area. Okay, we are going to do a different pattern for this next. We are going to fill it with floor space. And then we are going to create solid blocks here. This is not a great program to use for it, right? Here, let's ensure that this functions right. Where's my pixel brush? This is more like what we would actually see, where it is much more like there's an obstacle in the way, and the world won't let you go above or below the map. But left and right are just obstructed arbitrarily. So we go in, we do that. Now we go into our flow data. We're going to remove this. I do also want to put an age check on those two things to say if the source one is younger than the flow diagram, remake it. Okay, we're getting a lot of obstruction. One of the things we're going to need to do is put that texture on the field in order to see what's going on. Yeah. We need to verify the different parts of it. That doesn't seem right. No, that's okay. These are still zeros. Yeah, these numbers are way off. So they're not coming out actually normalized when we're putting them in. The fact that a lot of them are getting, like, caught in lines. Because it's this space here, these rings that actually push against them. This interior shouldn't. All right, let's put an else case in our logic where we are within range. If we want to catch a case where movement has been negated. Okay, a bunch of them are vibrating in place. That's just that they reached the player. This bar here that's puzzling. Almost feel like we should reverse the flow here and just have the walls push some distance out as well. That the wall always hard pushes towards the edge, but it's not that we're filling in as much space. Unclear. Because this is the circumstance that I want to avoid. I don't ever want them to be able to get hung up like they are. Now, some of it might just be the scale of the image. Like, there's actually some areas that they might be getting stuck. So let's do... It is now much bigger. This is also a good opportunity for us to see if there's a flaw in the shader, because that's a lot of data that we're loading to it right now. Nope, it got through it fine. 4096 by 4096 is supposedly kind of your limit. We should already be seeing impact. Nope, they have skipped right over it, which implies that there was a problem. Yeah. That doesn't seem right. So I'm betting that these are going to be 32 by 32. No, that's... Yep. So now they're weaving around them. This should be breaking it apart into segments of 32. Oh, okay, no. Yeah, it's not 32 here. I is less than width segment. Segment. Okay, we run it again. Oh. Nope. Messed up the math again. It's not less than height segment. It's Y segment plus segment start plus segment height. X segment start plus. Let's run that again just to be sure. Here we open it up again. Well, that one definitely doesn't seem right. To be within bounds of the image, and it also needs to be within the bounds of its segment, which is the start plus the width there. There we go. Okay. Now we run again. So probably what we're going to do is we're going to add in a couple of... Oh, there they go. They're hitting stuff. We can't see where some of the obstacles are at this time because we're not showing it. But we could see them deflect off of them. Delete that again. We're going to go into the code and we're going to expand the search radius to be 96. So that is the distance that something can move in a second by limit, but that's the arbitrary number that we're using. Access violation. Well. Let's... Okay, there's something that's causing it to overflow here. Trying to find out where the threshold is. Okay, there is something about the way that we're iterating with search range that is creating a problem. And since it's a full-on access violation, we don't have a clean image or a clean idea of where it is. Listen. Nope. Have been that. We don't have a zero check here. And A is greater than 0. Okay. Now let's go in and we're going to increase our search range again. process that. We look here. Doesn't seem correct. Delete that. Run this again. Access violation again. Somewhere we're getting out of bounds. Wait a minute. No, we should be getting... Not in collision that we're doing that. Let's go where we're opening the file. $4,000 by $4,000. We're going to divide that up into 32 by 32. $100 per. Should be okay though. Okay, is it happening during the GLSL or is it happening after? Nope. Okay. Somewhere in here it blows up. Oh, and it fails in the midst of it. So I think it is the GLSL. It is after we sync. There's something that goes wrong. I think that's going to be a problem for next time, which should be tomorrow. Oh, buttons. We'll need to look on this a bit more. There is a problem with the flow that we're doing. We need to be able to properly break it apart. We need to be able to properly break it apart, and it looks like there's something that's going haywire inside of the GLSL causing an access violation in that processing. We'll see. We need to make sure that the search radius is big enough that it influences movement more smoothly. And then we also need to refine the way that that we check for where the movement is going to be. Like, how do we have the wall stuff adjust the movement and to not be part of it, because we want to be able to apply that to more things. Both the wall pushes you away to keep you out of it, as well as the idea of the floor guiding enemies around. Two kind of different elements there. But we'll see. Hope everybody had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all that stuff. Those buttons are generally good, and I'd appreciate it if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means, as well as other options that are available through the link tree that you can find in my video descriptions and bio on Twitch. With that said, though, I hope the rest of your day is good, and I will see you next time.